Okay, in section 2, we're going to be talking about estimation, graphs, and mathematical models. So let's just knock these out one at a time. So first, estimation. In order for us to properly estimate, all right, which is just an educated guess. Oops, forgot the word guess. To the actual solution. To help us we can use rounding. So if you remember from rounding a long time ago, and if you don't, I'm just going to write down the rules anyways. So when we go to round, the first thing we do is identify and underline the given place value. Okay. Second thing we do is look to the right of the place value. To be rounded. And I like to draw an arrow. All right. And then the third is our conclusion. This is where we're going to actually round. All right. And there are two options for this. Option A. If the arrowed number, that's why I like to put an arrow underneath it, is 4 or less, the place value remains the same. Okay? Or part B. If the arrowed number is 5 or more, increase the place value by 1, all right? And then step 4 is replace all numbers to the right of the place value with zeros. Now, in red, unless you are rounding decimal places, then do nothing. All right? So we're going to do 2 examples just to refresh our memories. Okay? First example, let's round 4,382,005 to the nearest 100,000. All right. So I'm just going to rewrite the number. And then I'm going to follow my steps. Step 1, find the place value. Well, remember, going from right to left, there's the ones, tens, hundreds, 1,000, 10,000, 100,000. So I'm going to underline the number 3 because that represents the 100,000 position. Step 2, look to the right, draw an arrow. Now, step 3, if this number is 4 or less, the place value remains the same, or if it's 5 or more, we increase the place value by 1. Since this is the number 8, we're going to increase our place value by 1. So this is going to be 4,400,000. And then according to step 4, it says replace all zeros, or replace all the numbers with zeros. So there's my answer right there. All right. The second example, I'm going to use the golden ratio. Maybe you've never heard of that number before, but it's a very famous number. And we went around this number to the nearest hundredth. Notice the TH on the end, okay? Process, still going to be the same. 1.618. All right, step 1, find the place value. We want the nearest hundredth. The 6th is the tenths. The 1 is the hundredth. So I'm going to underline that. Draw an arrow underneath the number 8, which is to the right. Now I make a conclusion. That 8 is definitely bigger than 5. So the 1 is going to increase to the number 2. And because we are rounding decimal places, we do not place any zeros. So we just leave it like that. Let me go ahead and grab an example here from our homework. So here it is right here. And I'm just going to copy and paste this into our notes. All right, look at that. Beautiful. So let's obtain an estimate for the computation shown below by rounding the numbers so that the resulting arithmetic can be easily performed by hand or in your head. Then we're going to use a calculator, okay? So part 1, let's just go ahead and let's round these numbers. So when I look at 0.77, I'm just going to round that to 0.8. Make it easy for myself. When I look at 406, I'm just going to round that to 400. Make it easy on myself. That way, when I go ahead and multiply these, 400 times 0.8, even though I'm going to do this by hand, you could probably do this in your head, but the result is very easy to get. So 8 times 0 is 0, 8 times 0 is 0, 8 times 4 is 32. I have 0 decimal places in the first number, 1 decimal place in the second number. So the result is going to be 1 decimal place. Starting on the far right, I move it over 1 spot to give me 320. So that's our first result. And let's see if we can type that in back into our homework right here. So let me see if I can do it like this. Perfect. So I'm just going to type in 320 and check the answer. And it says, great, fantastic. Now the next part of the answer is, or the next part of this question is, what is the actual exact number? All right, so what's the exact value? Well, in this situation, they really want you to multiply the two numbers. So it was 406 multiplied by 0.8. And to help us, I'm going to just go ahead and use my calculator. So let me pull out my calculator. I think I have one on my computer. Here it is. You kind of maximize this, and let's do the detached LCD so we can actually see it here. And I'm just going to kind of wiggle these things around to help my life. So 406. Oops, didn't want to do that. 406 times 0.77 77. 312.62, so let's go ahead, let's type that in. 312.62. All right, check the answer. Good job, excellent, I'm feeling great about myself. And then the last question would be, how reasonable is the estimate? Let me see if I can zoom in here a little bit for all of us so we can see this a little nicer. There we go. So how reasonable is the estimate when we compare them? Well, if you look up here, 320, you look at the exact 312, I would say these are approximately equal. They're not perfect. All right, they're not perfect, but that's okay. That's what estimation here is for. And when I go ahead and do my final check, I get a well done. So you're going to see a bunch of these questions in the homework. And like I said, sometimes I really like to just show you homework problems. That way you can see them in action. All right. And then you can mimic them when you do your homework. Use this as a nice model. All right. The next thing I'd like to go over, all right, is going to be graphs. So let me go ahead and let's get this set up here. Here's the next problem, and it's gonna deal with a graph, and it's taken directly from our homework. So the circle graph shows the most important problems for the 17,447,295 high school teenagers in a country. Without using a calculator, estimate the number of high school teenagers for whom doing well in school is the most important problem. So first thing, they want to know doing well is the most important problem for these teenagers. So doing well right here is approximately 12%. So that 12%, we're going to round that to 10% because we don't want to use a calculator. We just want to get an idea. That's the first thing. Second thing, well, if we're going to round that, we might as well round the number of teenagers. So I'm going to round this to the nearest million. So we're going to call this 17 million. Now, the question that they're really asking us, all right, and I'm going to highlight it here. I'm going to highlight it in a different color, is they want us to estimate the number of high school students or high school teenagers for whom doing well in school is the most important problem. What they're really asking us is how many students find this to be the most important problem, right? How many teenagers, I keep calling them students, we'll call them teenagers, that's the word they're using, find doing well is the most important problem. All right. Now, mathematically, here's what we're really trying to ask. We're asking this question right here. What number is 10% of 17 million? Okay? Because this what number is going to represent the number of teenagers. Okay? Now, anytime we do a general math problem like this, all right, where we have like a general statement, the easiest thing to do is to find the word that represents equals. So for us, there's our equal sign. It's right there. The word is. On the left-hand side of this, what number? Well, that's going to be the left-hand side of our equation. What number? I have no idea. So I'm going to abbreviate with the letter X. On the right-hand side, the thing we have to remember is we never ever do math with percent signs. Okay? We always convert them into a decimal first. So 10% is really 0.10 as a decimal. So this is going to be 0.10. The word of means to multiply. And when we multiply, we're going to multiply by 17 million. Therefore, if you get out a calculator and you just type this in exactly how it looks, you're going to end up with 1,700,000 $700,000. So our answer is B. And that's all they wanted in this problem. So I'll see you in the next video.